Alright, our task at hand is to find and simplify the difference quotient for the function that looks like negative 3x squared plus 2x plus 3. So notice the difference quotient has the function f of x plus h, f of x, and then it has just the variable h. Know that f of x is given to us in the problem, and h is just a constant variable, so those are two parts that we don't have to do anything with. But before we actually use the difference quotient, we have to find what the function f of x plus h is equal to. So that means take all of the x's that are in f and replace them with x plus h. So take all of the x's that are in f and replace them with x plus h. Go ahead and distribute and find out what this polynomial is equal to. So I'm going to do x plus h squared. I'm actually going to write that twice, so I'll remember I need to multiply it with itself. And distribute this too. Now I'm going to come back and multiply these two sets of parentheses. So I'll have negative 3 times x squared plus x times h plus h times x, which is the same thing as x times h, and h squared, and I got all of that from multiplying those two sets of parentheses, plus 2x plus 2h plus 3. Go through this one more time and multiply this new multiplication, or this product, by negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times, and these two can actually combine to become 2xh. So negative 3 times 2xh becomes negative 6xh. And then negative 3 times h squared is negative 3h squared. Plus 2x plus 2h plus 3. Take a look. Is there any like term that I can combine? There actually isn't. So this is my final product for f of x plus h. Now I'm ready to use the difference quotient. So the difference quotient says start with that function f of x plus h, and that is negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h plus 3, and subtract from it the function f of x. And our function f of x is right here. It is negative 3x squared plus 2x plus 3. And put both of these functions all over h. So if you like, there's an extra step you can do, or you can do it straight from here, simplifying the numerator of this. I'm going to go one extra step, and I'm going to rewrite this, actually distributing this negative sign to this second set of parentheses here. So I have negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h plus 3 plus 3x squared minus 2x minus 3 all over h. So I did that step just to get rid of this set of parentheses. Now combine any like terms. Do I have anything that looks like negative 3x squared? I do. I have positive 3x squared, so negative 3x squared and positive 3x squared, and they'll actually eliminate each other. Do I have anything else that looks like negative 6xh? No, so go ahead and write that term down, and I've used it, so I'm going to cross it out. Do I have anything that looks like h squared? So no other terms that have an h squared. Go ahead and write that term down, and I used it, so I'm going to cross it out. Do I have anything that looks like 2x? And I do. I have a negative 2x. So 2x and negative 2x. And both of those terms will actually eliminate each other. Do I have anything that looks like a regular h? And I don't. So write that down and mark it out because we used it. And do I have anything that looks like 3? And I do, and it's negative 3. And those two terms would be eliminated. So if you've done this correctly, everything that did not have an h should have canceled out. So now I have negative 6xh minus 3h squared plus 2h all over h. And notice that each one of these is being multiplied by a common factor of h. So I can actually take that out So I'm factoring out the greatest common factor among these terms. And then I'm going to simplify my fraction by getting rid of the factor that's in the numerator as well as in the denominator. So I'm just left with negative 6x minus 3h plus 2. And this is the difference quotient simplified for f of x equals negative 3x squared plus 2x plus 3.